We passed back all the things that you had turned into me at any point. Sorry for my tardiness in getting some of that stuff back to you. I was waiting for some stuff to get made up and for me to double check that I had everything that needed to be made up before I passed it back. So I think I passed everything back. Soon I'll try to get get some keys scanned in and posted or dropped into the OneNote so you guys can look at my solutions or whatever to how I did things. I don't have those ready today because it's already been a day. So I've been running around trying to get caught up on everything. But I'll try to get that up here tomorrow or Monday. Should be able to get that in. If you guys have individual questions on your stuff I just passed back, I'll deal with those after we have a chance to kind of talk about the Chapter 2 test. But if you have individual questions on things, I'm happy to take a look and answer and tell you what I didn't like or what was wrong with it or whatever. If you're like, why is this wrong? Happy to do it. Okay. So we'll talk about the test description for Chapter 2, take some homework questions from Chapter 2, and then talk about due dates for the next sets of homework and stuff, and then may get out of your way and let you guys do some work. Sound good? Feel like a good last day of the week that we'll meet kind of day, right?
And then our test is Monday?
That's the plan, yes. All right. So your test description, you'll have 2 questions converting between degrees and radians or vice versa. 5 arc length formula questions. So like, if I give you different pieces, you should be able to find the missing piece or calculate a perimeter of a sector or something like that. You should be able to solve a triangle geometry style. You should be able to draw standard position angles like you did on the homework quiz. With that, make sure you're actually drawing the angle too and not just the rotation mark. I saw a lot of people not including both arms of the angle when they drew it or just drawing the terminal side or something. I was pretty lenient on the homework quiz about if you gave me kind of poo-poo, but it was correct because I knew what you were trying to do, but you didn't really show me what you're trying to do very well. But I'll be I'd want a little bit more on the test. So I'd want to see both arms of the angle, the initial side and the terminal side on your picture. I'd want to see the rotation mark for the angle that I indicate. So it should be going the correct direction, should have the right number of rotations in it, not just the terminal side in the correct place, which is probably all I really, had to have on the homework quiz. You should find 2 questions where you just want to find the exact value of trig function, so that one question where I ask you to write the 6 trig ratios using a point on the terminal side of a standard position angle. One question where I ask you to find the exact value for a trig ratio, given info on the other ratios. These are all things that were in the 2-4 homeworks, right? One question where I ask you to use the unit circle to evaluate a trig expression. That's just a lot of unit circling. There's some examples of that at the end of the review, I think. Yeah, so this kind of stuff. It's basically a glorified order of operations question, but and then I have 2 recaps or revisits from the Chapter 1 test. So these were probably the 2 things that we kind of messed up the most on average from the Chapter 1 test, and the two things that I'd want to see cleaned up a little bit from the Chapter 1 test. Looking at those would have been questions like 14 and 15 from the Chapter 1 test. So they're basically just, you're going to get a new version of that kind of a question. Is that everybody pretty clear as to what you'll have to do? So this is pretty narrow, right, in terms of the stuff you have to do. It's like, basically like 4 concepts, right? You have like the 3 different definitions of sine, cosine, tangent, etc. that you have to be able to do stuff with. And then like converting it radians to degrees and arc lengths is basically, like kind of what the test is, which is not bad compared to the first test that had kind of like a lot of stuff in there. More by and large, the tests tend to be pretty narrow because we got a lot of them. I think we have like 6 tests in the first semester is what the plan is, or something like that. Not counting the final. So like they end up coming pretty quick, a lot of them, where it's just like, you have 2 or 3 lectures and then it's time to review and do a test kind of things. So this is not uncommon. You should think that's good though, right? Narrow test is easy to prepare for. There's no less to study. It tends to be more straightforward. There's less to remember, Memory tends to not be as big of a factor. Those are all good things, right? Now, having to take a test a lot, well, that kind of stinks, but at least like the tests aren't going to be like gigantic and terribly difficult. You know what I mean? As opposed to if we crammed like 3 of these chapters together in one test, that would be el stinko. Everybody cool with the test description here, the format? Okay. Do you guys have homework questions or other kinds of questions for me before we talk about some due dates and then I get out of your way? All righty. Well, if you change your mind, you can always interrupt later.
Sophia has one.
Oh, Sophia does? Okay. I should have known, right? 50.
Okay. It's just like, man, no, you're just dumb. Yeah. Yeah, absolutely.
No, you're still off.
I should. You are. I am.
All right. So for 47 through 50, it's just asking us whether sine, cosine, or tangent are going to be positive or negative in this interval of angle measures. So basically all I want to do is figure out where is this interval of angle measures at? Is it in quadrants 1, 2, 3, or 4? So I notice in 50, this is in radians. So radian starts here at 0 radians. And I rotate to the left because I notice these are positive values. So then it's at pi over 2, pi, 3 pi over 2, 2 pi. Mr. Kulik, how are you doing this? I'm just taking like 90, converting it to radians, 180, converting it to radians, 270, converting it to radians, right? I'm just kind of continuing on. 5 pi over 2 radians, 3 radians, 7 pi over 2 radians. Just got to keep going. 4 pi, that's one of the spots. And then 9 pi over 2 radians. Aha, so we're talking about quadrant 1. In quadrant 1, the coordinates are x is positive, y is positive. So this tells me that cosine is positive. this tells me that sine is positive. And then because tangent is y over x, that's positive over positive, so that's positive also. Is that cool, Sophia?
Yeah, and then for the little numbers you did around, can you just use the unit circle for that, or like is it not on there?
Well, they only go from 0 to 2 pi.
Okay, so what if I did 4 pi and converted that to degrees, then just kind of like
Counted around? Yeah, this is doing the same thing I did. I just left it in radians
Okay.
because counting by halves and counting by 90s are, you know, not too much different for me. You know what I mean? No problem. Jazz.
I did 59.
59, sure. So it says find sine and tangent if cosine is pi over 3. Or I'm not sorry, cosine theta is 2 over 3, pi over 3. What are you talking about? And cotangent theta is negative. Well, I remember that, so the first order of business, I guess, let me just take a step back, is I have to figure out which quadrant to draw my standard position angle in, right? Like it's like, okay, I'm going to draw a picture. I know my initial side is here, but I don't know what quadrant I'm going to put the terminal side in. So I know that cosine is the same as x, so I know x is 2/3. But really all I care about is x is positive, because that tells me that theta has to be in quadrant 1 or quadrant 4. Cotangent, I remember, is x over y. And because x is 2/3, basically what I really care about is that x is positive. So 2/3 over y has to be a negative number. What's that tell me? Y is negative, right? So that means that theta would have to be in quadrant 3 or quadrant 4. The part I care about is that for both of those two things to be true, I have to be in quadrant 4. So that's going to be what my theta looks like, or at least an angle that's coterminal to what my theta looks like. So far, so good?
Yeah.
Okay. What I'm going to do now is I'm going to shift to the point on the terminal side of a standard position angle definition. I know that the x-coordinate is 2/3. Well, let's not even write that part yet. I know the x-coordinate is positive, and I know the y-coordinate is negative because we're in quadrant 4. Cool with that? Okay, if I go ahead and I draw my reference triangle there, bless you, I know this side is 2, and this side is 3 because cosine is x over r. I can then use the Pythagorean theorem to find y. So y is going to be the square root of 5. And because I know that that was a coordinate, I'm going to write it as negative square root 5. That's the y coordinate. And now I've got everything I need because I have that x is 2, y is negative root 5, and r is 3. So I think, what did it ask me? It wanted for sine and what was the other one? Tangent, okay. So sine is y over r, and tangent is y over x. And I'm done. Probably the trickiest part of this is just figuring out the quadrant that your terminal side has to go in. But all I'm doing is really looking at whether the x's or y's have to be positive or negative from the information that's given to me. And once I have that, it's usually not so bad. But notice I shifted between like different definitions inside of that same problem, right? Part of the time I was using like the unit circle definition when I'm trying to figure out what quadrant the stuff lies in. And once I have the quadrant, I drew the picture, I shifted to the point on a terminal side definition. I didn't really have to change, but it's just like the arithmetic is more convenient if I change, because now everything is just like integer side lengths basically, or exact value side lengths that are easier to come up with. Just less of a hassle. Yeah.
Could you also do 58?
Is it the same question or is it the other one?
It's like a...
Okay. Yeah, sure. Okay. So if I'm using the unit circle to do this, first thing I noticed is that like, hey, 480, that ain't on my unit circle. I should recognize though that 480 could be coterminal to something on our unit circle. Since I'm looking for something coterminal, I know my unit circle goes from 0 to 360. 480 is bigger than 360, so the coterminal angles I'm looking for are going to be smaller than 480, so I'm going to be subtracting 360. So that's going to be the same as cosine of 120. If I go to my unit circle and look up 120, the cosine is the x-coordinate. So I'm just going to write down -1/2. And I'm done. You're welcome. The trick was that I had to do the coterminal piece to get an angle on my unit circle. But if I can find an exact value for it where you're at, that will always be the case, that you can coterminal it down to something that you can use. You know what I mean? Sure. Anybody else? Ava. Sure. So the reference triangle piece is just what we did to draw the unit circle. So I'm just going to start by drawing my standard position angle. So 5/3 is just like 1 2/3. Agree with that? So if I'm going to draw this, 1 pi, let's write it. 1 pi is here. 1.5 pi is here. So like 1 2/3 is over here. Everybody cool with how I did that? So if I make my unit circle here, or my reference triangle, the key is going to be figuring out this piece. I know the whole thing is 2 pi. I went 1 2/3 pi's to the terminal. How many more do I have to go to get to the positive x-axis to complete 2 pi? 1/3 of a pi, right? 1 2/3 plus 1/3 is equal to 2. If I just forget about the pi's for a minute, everybody's cool with that? So this is just going to be pi over 3 or 60 degrees. So it's my 30, 60, 90 triangle then that I'm looking at here. This side is x root, well, we'll just call it -√3 because it's pointing down. That side is 1, that side is 2. And secant, I remember, is at the C there, is hypotenuse divided by adjacent. And I'm done. You're welcome. Yeah, Sophia?
So for that same question, say if I like did everything in degrees.
You could have converted it all to degrees and done it that way. It's no difference.
Like if I were doing if I was doing my thing at 300 degrees, then I went around. So what would I do from there? Like,
Just you're figuring out what this angle is here, being 60 degrees, just like we did. Right?
I just did 300 is 270?
No. So you went 300
Yeah.
to get to 360. You have 60 more to go because you have to like complete. We're always drawing our reference triangle back to the x-axis, never to the y-axis. We never draw that a triangle that way when we're doing trigonometry. Never, ever, ever. Very bad juju to do that. Everything gets all goofed up. Sure. Alrighty, we cool? We're cool. Let's talk some due dates here real quick, just so everybody's on the same page about when things are due, since it's the last class before the weekend. So this weekend on 9/25, that's Sunday, we're looking for numbers 1 through 50 from the problem set. You guys, I think Monday then is the test. And then on 10/2, we're looking for numbers 51 to 60. Worksheet 1 that I've included in the content library in the review. So worksheet 1 is just some more practice on unit circle and similar type problems. It just, what is there? There's, 15 of them or something. Most of them are just looking stuff up off the unit circle after you co-terminalize things, just to get a little bit more practice with that particular skill. And then some of these, given one value, figure out, some information about 2 of the trig functions, figure out what the value of some new one is. Just like we did for 59 or 60. It's just some more practice on that type of problem because it seemed a little lacking in the problem set. You know what I mean? Any questions about your due dates? Okay. I'm going to stop the recording here. You guys have the remaining time here in class to just work on whatever is the highest priority thing for you. So get your grind on, chop some homework time out of your weekend, get some stuff cleared up.